I am not at home, but I'm in good company because I'm down here in Cincinnati at Butler Tech, where they have a desk system Centurion that I'm clearly sitting next to. And the story of this machine is pretty wild. We discovered this machine from a random Twitter post from like 8 years ago. And I reached out to Butler Tech to see if we could learn more about this machine. And Mr. Hall, who's an absolute legend, invited me down to not only see the machine, but also work on it. But once I got here, I realized that Butler Tech is a pretty awesome place. I mean, this is a high school that teaches machining and welding and all sorts of epic information technology stuff. I mean, there's like a full-on dual CPU server motherboard sitting right here. And I mean, my high school had one computer class and all of the students knew more than the teachers. So definitely check out more about Butler Tech because I wish I would have had this kind of high school growing up. But we're here to work on this Centurion, and this is actually my third time here to get this one going because every time I think I've got it cracked, it throws a curveball at me. The first time I came down here, we really thought that we could maybe get it going, and then we realized that we were definitely in over our heads, particularly with this big hawk drive right here. So I actually took a lot of the stuff home. I took the entire card cage all the way back to Texas along with one of the platters, and we were able to pull an operating system off of one of those platters and confirm that the CPU and the MUX card and the disk controller cards and all that was good. But then I got talking to Mr. Hall about this, and this system had a pretty unique CPU in it. It had a CPU 5, and the two systems that I had at home had CPU 6s. And I really wanted to spend some time learning about the CPU 5 and the different quirks between the two operating systems. So we struck a deal, and I came up a second time, and I actually fully upgraded this system. I put a CPU 6 in it, 128K of memory, and I brought a whole second hawk drive, which is the one that's in it right now. However, this is a hawk drive that I have converted to a single platter only drive, so it's only got the fixed platter in it, and that's because we have trouble finding good hawk heads. And this had a full operating system on it. We got it in here, we got it hooked up, we booted fully into the operating system, and I said, job done, let's go, right up until I tried to create a new file, and then we had a disk fail error. And what happened was we had a bad ribbon cable. The ribbon cable could read, but it couldn't write. So every time I tried to create something new, it just blasted holes in the operating system, and we came to a halt right there. Where do we go from here? There's no removable media. There's no way to get new data onto this fixed platter. But there is a serial port, and we have lots of images of hawk drives stored on my laptop. So if we could copy one of those images on my laptop over to this fixed platter, we could get this machine up and going. And that's exactly what we're going to do today. All right, the first step is to replace the ribbon cable that goes from the computer to the hard drive, but it needs to be a pretty specialized 50-pin ribbon cable. It has to have a shield along the back of it. If it doesn't have this grounded shield on the back of it, you can get bit errors, and we could end up right in the exact same place where somebody tries to write something new to a sector and it doesn't work, and we end up blitzing a hole in that sector. So this is a spare 50-pin shielded ribbon cable that I had. It's a little long and a little dirty, but I think it'll get the job done. So I'm gonna get to work pulling this old one out, which is not easy because you have to kind of climb around like you're working on a car, laying on your back. So I'm going to get into it. After contorting myself into the tight space behind the desk, I could unplug the broken ribbon cable from the back of the drive. Then I unfolded myself from behind the machine and slid around to the front to unplug the cable from the disk controller card. And he shoots and scores. Goodbye, sector destroying cable. Before I power this thing up fully though, I want to purge it for a bit. It's been almost a year since this drive was last spun up. After sliding it all the way out, I'll unplug and lock the heads in position. Then we just hit the start-stop button and the drive will spin up, but never try to actually load the heads. After 30 minutes of letting it spin purge all the air out of it, I'll spin it down and reconnect and unlock the voice coil. Now this drive was still capable of fully booting because the blown sectors were at the end of the data written down on the drive. That means if the drive is still physically healthy, it should be able to read the initial program loader from track 0 and give us a name equals prompt. And it looks to still be working like expected. That's excellent.
Since the core operating system files are still intact, I thought I would try creating a new file for my transfer program. But as expected, when I tell it to make a new file, we get an abort 13 disk fail error. And the error specifically looks like a 1030. The 10 means a format error, and the 30 means the drive is ready and on cylinder. And this is totally expected behavior. Let's run a quick .sta, and we can see the opsys is still largely working. So let's next take a quick look inside the question mark folder. The question mark folder is where Centurion keeps all their testing utilities, and the one in particular we're interested in is TOS6. Now, what is TOS6? Well, in Centurion land, TOS, T-O-S, stands for Test Operating System, and even though they're calling it an operating system, it's really just a memory monitor, and there are a ton of different versions of this memory monitor. We've come across 3 different versions of it so far, but I imagine that there were quite a few more that were built with varying degrees of functionality and compatibility depending on when they were written and what CPU they were intended to be used with. This version, TOS6, the one that we're going to try and use here, is the biggest, baddest, newest version. And we've actually gone through and figured out what every single command that TOS6 can do is. And like all memory monitors, you can display and modify a value stored at a memory location, and you can also go to that memory location and start executing it. But there's a ton of other stuff in here, like we can display and modify individual registers, or we can display the contents of memory from a start to end point, or we can fill a certain section of memory with a known value. So TOS6 has a ton of functionality, and that is exactly what we're going to use to load in my program to copy a image file from the laptop over to the Centurion. Now, I wrote my program purely in Centurion assembly, and then I compiled it using the emulator, and then we extracted the executable out of our compiled image and pulled the hexadecimal out of it. So I need to get this hexadecimal into a location in memory. So we're going to hook the laptop up to the serial port, jump into TOS6, open up memory location 0100, and copy all of this data over. And then we can just tell it to go to 0100 and start executing code. So in order to start TOS6, we need to hit the select button on the front of the machine. And once we're at the name equals prompt, we'll type in $.tos6. We're going to tell it that it's on disk 1, and then we get the prompt 04F6. We're now in TOS6. So let's copy paste the raw hexadecimal from our program over to memory address 0100. The program has to live in 0100 because I programmed it with absolute addresses instead of relative addresses. This was a terrible idea, but for completely different reasons than I was expecting, and that'll become evident a little later. But at any rate, it looks like all of the data copied over correctly. And if I check the first couple of bytes here, 9070005F, 80C5, that's all absolutely correct. So now I just need to do a bit of terminal juggling. The ads terminal needs to be the one executing the TOS program, and the laptop needs to be plugged into port 3 for data transfer. So I just gotta move some plugs around. And with it plugged in correctly now, I just need to type in G0100, and yeah, it doesn't work. Not only does it not work, it falls back into TOS6 instead of halting, and that's absolutely not right. It looked like data was coming in correctly, and if I checked the first handful of bytes, they all matched up, but every time I tried to run the program, it would just fall back into TOS6. And that's really weird. Normally, if the code is wrong, it'll jump to some weird place or try to execute something that doesn't make any sense, and the CPU will halt. But it's going back into TOS6? Initially, I thought this was a memory thing, and so I pulled memory cards and I tried to roll the banks of memory around because I thought maybe I had a bad RAM chip that wasn't taking values that were being copied over, but no, that wasn't it. And actually digging through it a little further, I was comparing the full hexadecimal here with the hexadecimal that ended up in the memory monitor, and I could see that we were losing the plot at 01D9. As soon as we got to that memory address, the bits stopped copying over. And then it dawned on me. TOS6 is not running directly off the disk. As a matter of fact, when we tell it to load it, what it's doing is it's copying it off the disk and putting it in memory somewhere and then executing it from memory. And it just so happens that TOS6 lives in the same location that I'm trying to put my program. I mean, my program's only like a couple hundred bytes here, and I just so happened to pick the exact same place that TOS6 lives. So we have a problem here because I programmed my program to live at 0100. And if I want to move it to 0400 or 0600 or someplace that's not in the way, I have to essentially recompile the entire program, extract the exe out of the image, then pull the hexadecimal out of that exe. It's a non-trivial process, and we are deep into the day at this point, and I only have between about 7:30 and 2 p.m. to get this entire job done. So at this point, it's looking pretty bleak. But I brought a secret weapon. I brought this guy with me. This is the DIAG card that Ken Romaine had for many years. He kept this in his closet for about 40 years, and it has saved my skin more times than I can count. So Ken, thank you so much for that. And the reason that it's going to save our skin now is that this has a copy of TOS on it. It actually has what we're labeling DIAG TOS here, and it's like super bare bones. You only get two options. You can do an M to change the value of a byte at a location of memory, or you can do G to go to that location and start executing code. So I can use DIAG TOS to copy my raw hexadecimal over and then start executing from it. But we have a problem. In order to use this card, the ROMs that are on it are located at memory address 8000. Now this is fantastic because it doesn't overlap with my program that wants to be at 0100. However, it means that in order to get to memory address 8000, the bootstrap ROM has to check synth switch 1, which is a little dip switch on the CPU card, and then it executes a little bit of code that says jump to hex address 8001 and start executing code from there. But even though the desk system currently has a CPU 6 in it, it was originally a CPU 5 system that was built before the DIAG card came into existence. So the bootstrap ROM does not have the code in it to jump to 8001. And furthermore, if the DIAG card is plugged in during boot up, the entire system halts. So I've got my secret weapon, but I can't use it. And at this point, it's looking like I'm pretty much dead in the water. But Ken has done some pretty wild stuff that always makes me nervous, but he's been doing it for years, and I've done it a couple of times on this machine, and we've never had any problems with it, and that is hot swapping cards. Essentially popping a card out of the backplane while the machine is still running. This is like highly inadvisable for 99.9% of machines out there, but we've done it on the Centurion, and this thing's built like a tank, and it can do it, and that is pretty much our only path forward at this point. So what we're gonna do is we're gonna boot the machine with the DIAG card removed, get into TOS6, write a little bit of code that has a jump to 8001 in it. And before we execute that code, we will plug the DIAG card in while the machine is hot and on. Then we'll execute that code, which then jumps to the DIAG card and starts executing the DIAG TOS system from there. And then once we have access to that DIAG TOS, I can go in and play around with M0100, and I can see that it actually is now starting to change the values that were protected before. So we're now in a good place. I can actually copy my data over. So now that we're actually in a proper DIAG TOS, let's do that copy, get our hexadecimal over there again. And it seems like the hex copies over just fine. And after some more musical chairs with the terminal, it's time to open up the PC side of the communications program. And here's where we rapidly got out of my ability here. The PC side and the Centurion have to communicate with each other. On the Centurion side, it's waiting and listening for a ping from the PC of FF. When the Centurion receives FF, it's going to reply with FF to let the PC know that it's ready to activate the next sector. After that, 400 bytes plus 2 bytes of a CRC are transferred from the PC over to the Centurion. The Centurion receives these 402 bytes, puts them in memory, and it'll calculate a new CRC then it'll compare the new CRC with the 2-byte CRC that it received. If they don't match, it sends a 00 back to the PC to let the PC know that the CRC was bad, and the PC needs to resend the sector that it just sent. If the CRC is good, the Centurion sends FF back to the PC to let it know that the CRC was good and it can increment to the next sector. And then the Centurion goes about copying the 400 bytes of data that it just received over onto the actual disk, writing it onto the real platter. Then it increments the sector address, jumps it back up to send another FF to let the PC know that it's ready, and the whole cycle starts again. It goes all the way until it gets to the end of hexadecimal 3200 sectors, which is a lot. But I was able to write all of that in raw Centurion assembly. Rin 14500 helped me tremendously with this, so thank you so much for that. But this is a two-way street, man. This is a game of catch going on here, and I've only got one side figured out. So the other side has to happen on the PC. Now the good news about that is that it can be written in pretty much any language under the sun, but I don't know any other language under the sun. I've pretty much expended all of my knowledge on Centurion assembly, and I needed some help on the PC side of things. And that's where user of the Discord, M4Nusky, I have absolutely no idea how to pronounce that username, but they jumped in to help, and the program that they wrote was amazing. Not only that, they wrote the program in such a way that it's this really fantastic graphic user interface that is just dead simple to use. So I got that up and running, and it works flawlessly. It is an unbelievably good program. So Nusky, thank you so much for that. You really saved my skin on this one. So it looks like we've got everything up and running. The PC side is currently pinging the Centurion, waiting for response. So on the Centurion, I'll type G0100 and my program starts. And that's excellent news. It's actually running this time. I then tell it which platter to write to, which in this case is platter 1, and it starts the transfer process correctly. That is awesome. On the PC side, we can see it says progress and gives dots for each sector. At the top, there's also a little bit of text saying which sector we're on, which was very, very useful. Back on the Centurion side, we can see it did the RTZ successfully, and then we get a slash and a dot for each sector. The slash means that the calculated CRC matched the transmitted CRC, and the dot means that the write operation to the drive worked perfectly. But you can see it's also quite slow. We're transmitting at 19.2 baud, but there are 12,800 sectors in total, and when the sectors are counting up this slowly, it's gonna take a while. And it takes around an hour and 15 minutes to transfer 5 megabytes of data. Once the transfer is finished, let's hit the select button and try to load up the operating system. And, oh, right. I forgot that when using DIAG toss, I have to turn the parity control off. Fortunately, it's just a simple dip switch on the memory card. Moment of truth, the parity switch on the memory card has been switched over, and it should boot, and this should be an exact copy of the operating system install that I have at home. So I'll hit the select button. We got 3 RTZs out of it. We should get a name equals prompt showing up. There we go. We'll do @OSN. That's on disk 1. We'll hit enter. That's good news, I think. DOS 7.1e, it's probably trying to look for drives that have been sysgened that don't exist. Yeah, FNC control signal lag, abort 13. That's not good. I forgot that I had sysgened it for the Finch floppy controller. Oh, that's bad news bears. Seeing FNC control lag is not good. That's really incredibly bad news. And the operating system boot just hangs right here. It never gets past this point. So what's happening? Well, the image that I just copied over is an exact duplicate of the image that's currently on this machine. So I know it's a known good operating system install, but this machine has a bunch of stuff on it that the other one doesn't. This one has 2 Hawk drives, a floppy disk, and a Finch drive. Now the Finch drive and the floppy disk are both controlled via the same controller card called the FFC, Finch Floppy Controller. So there obviously isn't one on the Butler Tech Centurion, and the operating system is looking for this card and it's not there. And it's very strange that it hangs without that card there. I I actually even called Ken Romaine and we talked about this. It should totally move past that, but it's not. It's being stuck there, and I think our only option is to transfer again. But I have to use a different image, one that has had the sysgen set up for a single Hawk drive. Now, this is not really a big problem because we have the emulator and we're building images on the emulator with all kinds of different settings and setups. And we just so happen to have an emulator image that is set up for a single Hawk drive. But now we're running into a problem of file formats. The emulator is using a file format that was decided by CCDP written by Gavin like 2.5 years ago. Now, the way that the CCDP format works is that there are 400 bytes of data, a 2-byte CRC, and then 110 bytes of padding of the value FF. And Gavin did this to get it to an even 512 bytes. But since we're doing just raw transfer over the serial port, that extra 110 bytes of padding seemed unnecessary. And also, if we're searching for specific things within the file, this is quite tough because we don't really know exactly which sector we're looking at. So I sat down with some other members of the community, notably Ren14500, and we came up with a new file format for our raw image files. And it starts with 8 bytes spelling out Hawk dump, letting us know that this is a dump of data off of the Hawk. We follow that up with 2 bytes containing a carriage return and a line feed. Then we have a 2-byte sector address. Then we followed up with 400 bytes of data, then a 2-byte CRC, and another 2 bytes of a carriage return and a line feed. This means that we can use those carriage returns and line feeds and the text of Hawk dump to differentiate between sectors when we're looking at the raw data, and we can also search for specific sector addresses. So we can take a look at one specific sector. The problem is that these two types of formats are dramatically different. And I built my program with this second format in mind, but the emulator is still using the old format, and all of the image files that we have that work with the emulator are using that old format. And this is where M4Nusky saved my skin yet again, because they wrote their PC side transfer program to be compatible with both file formats. Oh man, I thought so many times during this, I thought I was dead in the water, and this was the one that I thought was the final nail in the coffin because I never tested it with that older format. I only tested it with the newer format here at home. So I pulled that older format off, I threw it into the program, and we started the transfer again, and I think it's gonna work. All right, new image has been transferred over and it's transferring correctly. That's what the dot and slash means. It means the CRC was good and the sector was written correctly, but I don't know if it transferred the right data. It just sent data correctly. So the best way to find out is to hit the select button. If we get a name equals prompt, that is very, very promising. That is very, very promising. Let's go at OSN on disk 1. Welcome to the Centurion. That's a good start. There we go. We got it. We already got further than we got previously. I think if we've made it this far, we're good. Let's see if it says a, come on, CRT0 ready if we do a .sta. There we go. 0 should always be stars because this drive is missing the removable platter. So we should only have 1. And if I do a .dir1, this should be exactly the same as the image that we were using in the emulator, which is pretty wild. I've never actually tried to do that. So that is awesome. We should even be able to run the general ledger because I think that is on this platter. So if I do GL menu here, and we'll just come up with a key number and a disk number, this should load up the GL menu. Yeah, there we go. General ledger application. Okay, so let's create a new file. I think we should have CED on here. So if I do s.ced, and we'll create a file just called Valo because he's here hanging out with me. And we'll put that on disk 1, and we want the CRT to be CRT0. I'll turn write protect off. It's going to tell me that the file does not exist. Do we want to create it? We're going to hit yes. This is where we failed before. But we successfully created a new file, so if we hit append here and I say hello Valo, and I hit an exclamation point, and we finish our append, and we quit out of this, should copy it over, and I should be able to do an s.crt Valo on 1, and hit enter, and it should print out hello Valo. That is a fully working Centurion. I did not think we would get there today, but we did it. I genuinely did not think we would get there, but that is a fully functioning Centurion desk system. Almost fully functioning. We still don't have the removable platter, but you can make new files, you can edit them, you can delete them. It works like it was supposed to work, and it was an absolute journey to get here. And the reason that I wanted to use the word journey to say that is because there is somebody here who's been with me on every step of that journey. We have my good buddy Valo. So say hi to the camera.
Hi, everyone.
So Valo, actually, you went to school here at Butler Tech, right?
Yes, I did.
And so in the very first episode that we did on the Butler Tech Centurion, you were a senior, and he helped me hoist this big, heavy hawk drive around, and he's been here every step of the way on every single episode we've done, every time I've been here to Butler Tech, even though you've graduated and you've got a job for almost 2 years now, right?
Yeah, it'll be 2 years next June.
2 years next June. So even though he's graduated and out in the workforce, he's still coming back to help me with this Centurion. And I'm gonna release this thing into your care, man. This is now your baby. Are you excited about it? What are you excited about it?
I'm excited about it because it's a piece of history that it's not cataloged anywhere. So a lot of this is very experimental. It's a lot of the same excitement I have for touching new hardware and stuff like that.
Okay. So, I mean, that's it. The mystery is what drew me in on the Centurion, and so I'm glad we're drawing new people in. So I'm releasing this into your care, but I do think that I will be back up here to help you one more time, because there is a TI 810 Centurion branded printer over there, and I just spent an entire week getting one of those going for me. I think it would be dope if we had another TI 810 printer hooked up to this like it was originally meant to. But man, this is epic. I am so happy that's going. So thank you so much, man.
No problem.